We want to find the limit as x approaches infinity of sine of 1 over x over 1 over x. And you could totally find this limit using the L'Hopital's rule, but if you're in an introductory calculus class and you haven't gone over derivatives yet, you probably won't know how to use the L'Hopital's rule. But luckily, there's another way that you could solve this problem, and that's using this known limit here. So it's assumed that this limit has already been, proven in your calculus class, but it's a pretty common limit. And it's the limit as h approaches 0 of sine of h over h equals 1. Now, h could be any variable here. I could have written it with x as well, but just to avoid confusion, I'm keeping the variable in the limit we're trying to find and the variable in our known limit different. All right, so we want to find this limit using this known limit. So let's first think about what's similar, and then we'll think about what's different. So this already matches up with our limit because what is inside the sine function is also what it's being divided by. So in this case, it's like our h is 1 over x. So we're good there. What's different is that instead of having what's inside the sine function approach 0, we're actually having x, which is like the reciprocal of what's inside the sine function, approach infinity. And so what we want to turn this into is we want it to get it to match up with this, which is h approaching 0. So in this case, it would be what's inside the sine function, 1 over x, approaching 0. Now, but we need to reason our way through how we could rewrite the limit as such. Okay, so we know from our limit that x is approaching infinity. Now the question is, we want to rewrite this as 1 over x approaching, hopefully 0, because 1 over x is what we have inside our sine function. So if x is approaching infinity, then 1 over x is approaching, well, if x is getting larger and larger and larger until it's getting really close to infinity, 1 divided by a super large number is 0. So what we can say is because x is approaching infinity, therefore 1 over x must be approaching 0. And so we can actually rewrite the given limit as the limit as, 1 over x approaches infinity of sine of 1 over x over 1 over x. And now at this point, you could just apply our known limit because everything matches up. What's inside the sine function is what it's being divided by, and it's also the thing that's approaching 0. And so you could say that this is equal to 1. But if you just want to be, get it to match up exactly with this known limit here, you could just take the extra step and write, you could say let 1 over x equal h. And so then if you rewrote your limit with this substitution, where 1 over x equals h, you would just have the limit as h approaches 0 of sine of h over h, which of course at this point exactly matches up with our known limit, and so you could definitely say that's equal to 0. That last step isn't necessary, but if you wanted to do that, you could. All right, that's it. Hope this was helpful.